the function. Simplify the function fully. I can plug it in. You can say you can. I said yes. Oh, yeah, it's possible, but it's always the best thing. The best practice is to simplify the function with no absolute value. So x plus 4. Can anyone tell us what we need to write? Oh, I'm sorry. Can anyone tell us what we need to write? Please try. Too big. Anyone? What is the definition of the absolute value? The definition of the absolute value is the absolute value of whatever equals whatever when whatever is greater than or equal to 0, or negative whatever when whatever is less than 0. How do I write that?
X plus 4.
Yes.
When x is...
When x plus 4 is greater than or equal to 0. We have to show that, and we'll solve it in a moment. You're right.
And then negative x
plus 4 quantity when x plus 4 is less than 0. So now I'll simplify it, and I have x plus 4, and move 4 to the other side when x is greater than or equal to negative 4, or negative x plus 4. I will refuse to solve this. If it's not here, it has to be in the other way. Do not ever waste your time solving the second one. It will be a waste of time. So now the entire function, x plus 4 in absolute value minus 2x, must have two options because this piece has two options. So can anyone tell us what we write first? And yes?
Would we combine the like terms? So would it be like
let's write it for everyone to see first, but you're correct. Yes, you can do that. But let's
so x plus 4 minus 2x.
Very good.
And then negative x minus 4 minus 2x.
Brilliant. Awesome. So then now equals, and you said x minus 2x, indeed, minus x plus 4 for x greater than or equal to negative 4. Negative x minus 2x, negative 3x minus 4 for x less than negative 4. Awesome. This is indeed fully simplified. Now I want to uncover and see what they're asking. Well, they're asking as x approaches negative 4 from either side. I cannot answer before I find the limit from the left and I find the limit from the right. Why? Because I have the limit from either side. This would have been very clear if I had positive from the right or negative from the left. No, but it's not clear. I have to determine both. So which function do I use for limit from the left of negative 4? And I will put it here. Which function do I use for limit from the right of negative 4? And I will put it here.
We would use the first piece for the first one, but from approaching from negative.
Negative 4 from the left.
Oh, never mind. Sorry. Second one.
Good. So negative 3x minus 4. And of course, negative 4 from the right will be negative x plus 4. Good. So now let's determine the first limit. Can anyone give us the first limit and somebody else the second limit? So Tom, would you give us the first one or the second one, your preference? Tom is either muted or he's not with us. Landon, do you want to try?
I'm not sure.
Okay. Mason, would you like to try?
Yeah, give me a second.
Awesome. Will you tell us what we need to do? That will be great. Aaron, will you tell us any of the two?
Yeah. So for the -4 approaching from the left, it would be 8. You
So
plug it
this
in.
is 12 minus 4 is very good. It's awesome. 8, great job. Anyone else would like to give us the second one? Dakota, would you like to give us the second one?
Isn't it also 8?
Yes, awesome. So what is our conclusion from either side then?
It's 8.
That's it. Awesome. Was a very good example. Oh, and I picked it. I'm kidding. So it was a very good example to see that this is a limit from either side. I have to check both. I have no choice. I have to check both and then I decide. Because if this is 8 and this is 7, what do I put as the answer? If I get 8 and 7, what will I put here? That's it. That's it. Awesome. Great job. Okay, I would like to talk about something called... Any questions? Sorry. Any questions? Any questions? Something called the squeeze theorem. The squeeze theorem. What is this? Well, there are situations in which we cannot determine a limit. And the situation fits the following category. Let's suppose I have a function which is g of x. Let's suppose I have a function that is f of x. And let's suppose I have a function that is h of x. So this is a, so near a. Now let's suppose I have a function that is this, and this is h of x. Okay. This theorem has two hypotheses. Hypothesis number 1, it says h of x is squeezed or sandwiched near a. How is it squeezed? As we see, f of x is below and g of x is above. But near a, not everywhere. I only care about this. And yes, that should not go above. Okay, and number 2, if the limit of g of x and the limit of f of x as x approaches a, if they both exist and they are the same number, a wild guess from 1 and 2 by the squeeze theorem, what do you think we will conclude about h of x, the limit of h of x as x approaches a from either side? Of course, if I show these two, if I show that h of x is squeezed near a, sandwiched between f and g, and if I show that the limit from both bottom and top exist and they are the same number, what do you think we conclude about this?
It would also be.
Of course, by the squeeze theorem, the limit is also L. So let's work on an example here. Okay, that's my page 5. So I'm sharing my screen. So 41. Prove that the limit as x approaches 0 from x to the fourth times cosine 2 over x is whatever. They shouldn't tell us what it is, but they do. So every time we calculate a limit, unless it's a very specific situation or others that we looked at last time, we have to plug it in. So let's plug it in sequentially because we look at every piece separately. What is the target for this when x approaches 0?
Zero.
Absolutely. What is the target for this when x approaches 0? Careful, it's not from the left or from the right. So let me refresh your memory on how to graph 1 over x or 2 over x, which is a very important function. So 2 over x or 1 over x will be the exact same graph, minor differences in numbers. So this is 2 over x or 1 over x. The graph is the same. So see what happens as x approaches 0 from either side. What is the left limit and what is the right limit? What is the left limit?
X equals 0.
The left limit of the function, the target of the function when x approaches 0 from the left.
Negative infinity.
Negative infinity. What is the target of the function when x approaches 0 from the right?
Positive infinity.
Yes. So what is the from either side of 2 over x? What should I write here?
D&E.
Yes. So I'm asking you now, how much is cosine of d and e? Well, it's d and e. You could argue by saying, well, wait a second, 0 times d and e is 0. No. No, we cannot conclude that. So here is how we calculate this limit. We start with cosine. We start with this piece of the function. The function is not cosine. The function is this product. But we start with one piece of it. So we're going to say cosine of 2 over x. And we know that cosine is a function that is bounded. This number below and this number above. Anyone remembers what is the smallest number that cosine can take and what is the largest number that cosine can take?
That'd be -1 and 1.
Brilliant. Thank you very much. Thank you very much. Okay. So right now, I have this function in the middle. But I don't want that function. I want the x to the fourth times that function. What should I do to all three sides so that the middle part is exactly x to the fourth cosine 2 over x? What should I do to all three sides to get that in the middle? And whatever I get on the sides, it doesn't matter.
You multiply all the sides by x to the power 1.
Brilliant. Multiply everything by x to the fourth. But I have a problem, potential problem. X to the fourth has to be positive. Because otherwise, if it's negative, then I have to switch the inequality symbols. Is it positive always? Is x to the fourth always positive?
Yeah.
Yes, because power 4 always does that. Now, yes. So also I have to make sure that I'm not multiplying by 0. Is x not 0? Yes. We really mean it. By this, we say x approaches 0. We absolutely mean x cannot be 0. X approaches 0. Otherwise, we will use the equal symbol. But we're using an arrow, meaning x gets closer to 0, but does not equal 0. So both conditions are fulfilled. Therefore, I can multiply all three sides by x to the fourth. Otherwise, I can't. Negative x to the fourth less than or equal to x to the fourth. Cosine 2 over x less than or equal to x to the fourth. This is the first hypothesis of the squeeze theorem. Below, I have negative x to the fourth. Above, I have x to the fourth. And in the middle, I have x to the fourth cosine 2 over x. What is the second step or the second hypothesis that I have to show?
What the limit of each is?
Very good. The limit of negative x to the fourth, the boundaries, and the limit of x to the fourth when x approaches 0. Can anyone give us the answer for these two limits?
It will be 0.
Yes, of course. Now from 1 and 2. From 1 and 2 by the squeeze theorem. Can anyone conclude for us the limit as x approaches 0 from x to the fourth times cosine 2 over x? What would that equal to?
I think it would be 0.
Absolutely. We showed the squeezing part. We showed the limits. So by the squeeze theorem, because both conditions are fulfilled, both hypotheses of squeeze theorem are fulfilled, the answer is 0. So unfortunately, for this kind of limit, there is no other argument. We have no other steps. So we learned a lot of different situations. The 0 over 0, the number that we get, straightforward. The squeeze theorem, we looked at absolute value limits of functions that have absolute value in them. We looked at expressions that had to be simplified before plug it in. It's on and on and on. Any questions?